Hello everyone, welcome back. In our previous lecture, we were introduced to NLP and we discussed what is NLP and why it is important and where it is used in our daily lives. In today's video, we are going one step further and we will understand how computers process human language before performing tasks like translation, sentiment analysis, chatbots, or spam detection. See, imagine you type a sentence into ChatGPT or Google Translate. Does the computer understand your sentence immediately? The answer is no. So, before understanding the meaning of a sentence, the computer performs several pre-processing steps. So, this sequence of steps is called the NLP pipeline. In today's lecture, we will learn these pre-processing techniques and then I will show you how to implement these practically using Python and Colab. So let's first look at the learning outcomes for today's session. So by the end of this lecture, you should be able to explain what an NLP pipeline is and why it is essential in natural language processing. So we'll also understand the concept of text pre-processing. Then we will study four important pre-processing techniques. The first is tokenization, and the second is stop word removal, and the third one is stemming, and the next one is lemmatization. At the end of this lecture, we will implement all these techniques using Python in Google Colab. So now let's understand the NLP pipeline. So the word pipeline simply means it's a sequence of connected steps. Here the first stage is input text. This is the sentence entered by the user. For example, I love learning NLP. So at this stage, it is just ordinary human language. And the second stage is text pre-processing. Here, the unnecessary symbols, punctuation marks, extra spaces, and irrelevant words are removed. Now the sentence becomes cleaner and easier for the computer for further processing. And the third stage is feature extraction. In this stage, the clean text is converted to the numerical because machine learning algorithm cannot work directly with the words. And the next one is machine learning or deep learning model. So the model analyzes the set of features and learns the patterns from the data. So the final step is the output prediction. For example, if the task is sentimental analysis, the model predicts whether the sentence expresses a positive, negative, or neutral sentiment. So whenever we interact with applications like ChatGPT, Google Translate, or Gmail spam filter, a similar NLP pipeline works behind the scenes. So here I had given one example. The input is I love learning NLP. So NLP will analyze the sentence and it will give the output like, so it is the positive sentiment. Now we'll focus on one of the most important stages of the NLP pipeline, that is text pre-processing. It is the process of cleaning and preparing raw text before it is analyzed by an NLP model. So why it is necessary, why we have to do this is, actually the human language is messy. So people use uppercase and lowercase letters, punctuation marks, emojis, abbreviations, unnecessary words, and we do spelling mistakes also. So for example, look at the sentence. I love NLP. So although humans understand it easily, but a computer treats uppercase letters, punctuation, and lowercase letters differently. So here, after processing, the sentence becomes I love NLP. So this is converted to the lowercase letter. Now the text is cleaner and more consistent. And what is the main advantages of text pre-processing is it will remove the unnecessary information and it will improve the model accuracy and it reduces the processing time. Finally, the most important application is it will convert the unstructured text to structured information so that computers can analyze it efficiently. So it is one of the important steps in NLP. The next pre-processing step is tokenization. So here the token means it is a small unit. Tokenization, it is the process of dividing a sentence into smaller units, that is called tokens. So these tokens must be words, sentences, or even individual characters depending on the application. So consider the example, ChatGPT helps students. So this is the input example. So after tokenization, it becomes ChatGPT helps students, and even the full stop is treated as a separate token. So why we need to perform tokenizations? Because computers cannot understand complete sentences directly. So instead they process one token at a time. So these tokenization is widely used in chatbots, search engines, machine translation system, question answering system, and text classification. Without tokenization, NLP application cannot function effectively. The next one is stop word removal. So this is also one of the pre-processing techniques. So stop words are common words that appear frequently in a language, but usually they don't contribute much meaning to the sentence. So example of the stop words are like is, the, of, and, to, for. So these words are called stop words. Let's understand with this example. Consider the sentence. This is a book about NLP. So if we remove the stop words, the remaining words are book, NLP. So notice here the important information is still present. We can still understand that the sentence is about a book related to NLP. Removing the stop words has several advantages. First, it reduces the size of the text data. Second, it reduces the amount of computation required by machine learning algorithms. Third, it helps the model focuses on only meaningful words instead of very common words. So sometimes stop word removal is not always beneficial. For example, in sentimental analysis, words like not can completely change the meaning of a sentence. Consider these two sentences. Like I like this movie, and another sentence is I don't like this movie. If we remove the word not, the second sentence is incorrectly becomes positive. So we need to apply stop word removal carefully. Next pre-processing techniques is stemming. Stemming is the process of reducing words to their root form by removing prefixes or suffixes. So look at the example. Here, this is the original word and this is the stemming word. Playing becomes play. Played becomes play. And the running becomes run. Studies become study. So these different forms of a word are reduced to a common root. So the advantages of stemming is it is very fast because it uses a single root instead of consulting a dictionary. However, stemming has one important limitation. It produces words that are not valid English words. It will not check the dictionary. For example, the last word I have given is studies, study. So as humans, we know that study is not a proper English word. This happens because stemming simply removes the part of the word without checking whether the result is meaningful or not. Even though stemming is not perfect, but still it is widely used in applications like search engines and information retrieval because of its speed. The next pre-processing technique is lemmatization. Lemmatization is more advanced than stemming. Instead of simply removing prefixes or suffixes, it converts a word into its dictionary form, also called the lemma. So consider this example. Here the cars becomes car and the running that is converted to run and the better that is becomes good. Notice here all these outputs are meaningful English words. Unlike stemming, lemmatization uses a dictionary and grammatical rules to determine the correct base form. So because of this, Lemmatization usually produces more accurate results. But one of the disadvantages of lemmatization is it will take more processing time than stemming. So modern NLP applications like chatbot, machine translation system, and question answering system mostly they use a lemmatization compared to the stemming because this will preserve the correct meaning of the words. That is very important. And next, let's compare stemming and lemmatization. The first difference is the approach. Stemming is rule based, it removes prefixes and suffixes using predefined rules. But lemmatization is dictionary based, it checks the words in the dictionary and applies the set of grammar rule before finding the correct base form. And the second difference is speed. Stemming is faster because it simply applies rule, but lemmatization is slightly lower because it will check the dictionary and considers the grammar rule. And the third difference is the output. Stemming may produce words that are not valid words, but in lemmatization, it will convert the proper value, that is, which is the valid dictionary word. So always this is stemming is faster than lemmatization. So in model applications, lemmatization is generally performed because it produces more meaningful results. So these are the examples of tokenization, stemming, and lemmatization. So tokenization overall is the process of splitting text into smaller units called tokens. Stemming reduces the word to their roots by root form by removing prefixes or suffixes. Lemmatization produces meaningful dictionary words. That's the difference between stemming and lemmatization. So next we will go to the Google demonstration. So now that we have understood the theory behind the text processing, let's we'll see the demonstration. We will perform 4 processing steps: tokenization, stop word removal, stemming, and lemmatization. So our first step is we need to install the required Python library. Just go to the Google Colab, use your Gmail ID to open this. So first we need to install the required Python library. So here I am using the command pip install NLTK. So here the exclamation mark tells Google Colab to execute. This is the system command. And pip it is a Python package manager and it is used to install external libraries. NLTK stands for Natural Language Toolkit. It is one of the popular library functions for natural processing. It provides many useful functions like tokenization, stemming, lemmatization, and stop word removal, and much more. Now let's run this cell. Okay, once the installation is complete, we can use all the functions provided by the NLTK. Next, we need to import the set of packages. The first line import NLTK already we have imported. The next 4 lines download the datasets required by NLTK. PUNKT it is used for tokenization and stop word contains a list of commonly used English words and WordNet it is a dictionary used for lemmatization and OMW 1.4 it gives the multilingual word information that supports WordNet. So next we need to see some lines. So we need to import some specific tools that is word tokenize. It will split a sentence into individual words. Then stop words, it provides the list of stop words. Then we have used port stemmer, that is for performing stemming. Then we have used WordNet lemmatizer that perform lemmatization. So we need a tokenizer, stemming, lemmatization. So for that we have imported the package. We will run the cell. So all the record sources have now been downloaded successfully. Now let's create a sample sentence. We store the sentence inside a variable named text. The sentence will be used throughout our pre-processing test. The print function displays the original sentence. Just I am storing this in the variable called text. So let's run the cell. See, this is our original text. As you can see, it contains uppercase letters, stop words and punctuation. So in the next step, we will gradually process and clean this text. So next we are going to perform tokenization. The word tokenize, that is the function, it takes the sentence as the input and split it into individual words and punctuation marks. Finally, the result is stored in the variable called tokens. So the next two lines print the heading and then display the list of tokens. So we will print the tokens. We'll execute this cell. Just observe the output carefully. Instead of one long sentence, we now have a list of separate tokens. Each word has become an individual token, and even the period at the end is treated as a separate token. So that is the function of tokenization. It is the first step and it is one of the important steps in NLP. Now let's remove the stop words. Here the first line retrieves the English stop words from the NLTK and stores them in a called stop words. A set is used because checking membership in a set is very fast. Next we will create an empty list called filtered words. This list will store only the important words. Now look at the for loop. It processes each token one by one. The condition word dot lower not in stop words. Convert each word to lowercase before checking whether it is a stop word. So this ensures that word like capital THE and small THE are treated the same. If the word is not a stop word, it is added to the filtered words using the append function. So finally we will print the filtered list. Let's run the cell. Just see here. Notice that the common words such as is, one, of, and, the. So these words have been removed. So what remains are the more meaningful words that are useful for analysis. Next we'll go to the stemming. First we create an object of the Porter stemmer class. Next we create an empty list called stemmed words. So using a for loop, we process each word in the filtered list. The method stemmer.stem removes prefixes or suffixes to produce the stem of the word. Then the resulting stem is added to the stemmed words list. So finally we will print the stemmed words. We will execute this cell. Just see this output. Words like natural become nature and processing become process. Artificial becomes artifici, and here also intelligence become intelligent. So these terms are not always valid English words. That is the one of the limitation of stemming. It will not produce actually meaningful words always. This is the output of stemming. So next we will go for lemmatization. We create an object called word net lemmatization class. Again we create an empty list for the lemmatization words. The for loop processes each word. The method lemmatization, not lemmatize word, converts word to their dictionary or base form. So each lemma is added to the list. That is, each word is added to the empty list. So finally, we will print this results. Let's run the cell to see the output. Notice that the words remaining meaningful. For example, fields was converted to field, stemming, processing, language, and natural. See all the words, these all are meaningful words. Field, artificial intelligence. So unlike stemming, lemmatization aims to produce valid dictionary words. So it always produces valid words compared to the stemming. So when we compare stemming and lemmatization, we'll run the cell. Stemming will not produce valid words, but lemmatization will produce the dictionary based words. That is the difference between the stemming and lemmatization. So finally, we will try this example. This program asks the user to end a sentence. So I'm going to give a sentence. Machine learning is like changing the world. Just I'm giving dot and exclamation mark everything. I'm giving enter. Just see this. The sentence is tokenized, stop words are removed, and the results are displayed here. See here, machine that is done tokenization, then learning. The stop words like is, that everything removed. Only the meaningful words are there, and dot exclamation that is also treated as a separate word. Like that, it will be removed. So this is the basic pre-processing techniques actually. Now we have completed the practical implementation of the four main text pre-processing techniques: tokenization, stop word removal, stemming, and lemmatization. So these techniques form the foundation of many NLP applications, including chatbots, search engines, sentimental analysis, and machine translation. Every application will use basic pre-processing techniques. Now let's return to the presentation and we'll see the key concepts. Finally, we'll come to the quiz. The question is, which processing technique splits a sentence into individual words? Already we have studied tokenization, that is the process of converting a sentence into words. Stemming and lemmatization, stop word removal is different. And the next quiz is, which processing techniques converts words into their dictionary form? So answer is lemmatization. Already we know that stemming will not produce valid words. Only lemmatization will convert the words with the dictionary and will give you the exact dictionary word. Okay, next class we will see the next core concepts. That is the next what after this pre-processing techniques. What is the next function will be performed by NLP. So that we'll see in the next class. Thank you everyone.